Assalamualaikum and good day everyone. We will continue our topic in electrostatic in medium with the subtopic of the boundary condition. For this subtopic, I already prepared 3 videos for you, and this is the part 1 where it is an overview of the boundary condition. To make an analysis in boundary condition, let's say we have this kind of structure, and let's say this is our boundary, which is flat and smooth, and this line indicates that it is normal to the boundary. And here we know that this boundary separate 2 types of medium, and the upper part we write it as a medium number 1, and the second part we name it as a medium number 2. And now what we want to know is what happened to any electric field when it penetrates from medium number 2 into medium number 1. So I think we know that the E will be reflected. And here I'm going to draw it. This is our E2. Okay. And this one will be refracted somewhere, maybe here. So this is our E1. And here is the point where E2 meets E1. So what we want to do next is we are going to create equation at this point where we want to relate the E2 with the E1. Okay, the general observation that we can make now is when we change the medium, the direction will change. So it is a dynamic condition. And in each E, okay, either in the upper part or in the lower part, the E must have a normal to the boundary and tangential to the boundary. The normal to the boundary can be drawn as this line, where it is 90 degree to the boundary, and I will name it as E1, and since it's normal to the boundary. And the second vector is the tangential to the boundary. So it is make 0 degree with the boundary because it is a parallel to the boundary. So now I will name it as E1T. Okay, so what happened in the medium, that E must be normal and tangential to the boundary. So if we have the normal and the tangential component in the E1, so E2 will have the same thing. But now I'm going to name it as E2 tangential, and this one as E2 normal. Okay, so from this diagram, what we can see is E1, okay, E1 is equal to the summation of E1n plus E1t. Okay, while E2 is equal to E2n plus E2 tangential. Okay, as you can see here, we have element of the normal element in E1, normal element in E2, the tangential element for E1 and the tangential element of E2. So now, to make our life easier, we will create a equation which consider the normal condition only. Okay, and another one is tangential analysis. Okay, so now I'm going to name this normal analysis as a boundary condition number 1, or I can name it as a normal component. Okay, well, the tangential component will be the boundary condition number 2, or tangential component. So after this, we will have another 2 video where the first video will discuss about the first boundary condition and the second video will discuss about the second condition. So that's all for this video. Thank you.